Hi, welcome to Such a Study Tech. Today topic is 01 knapsack problem. So there are two types of knapsack problem. One is the fractional knapsack problem, another one is 01 knapsack problem. In fractional knapsack problem already we are discussed by using greedy method. Now we are discuss 01 knapsack problem by using dynamic programming approach. So here it is 01 means, for example, I am consider the four objects, object 1, object 2 and object 3 and object 4. So xi is a decision variable. So which object you want to carry, which object you want to ignore. So if you can carry that object, that means if you can put that object into the bag, so you can get that profit. So here it is, either you can put that object, the x value is 1, you cannot put the object, the x value is 0. So xi either 1 or 0, either 1 or 0, xi value either 1 or 0. For example, here I am consider the 4 object, so these are the possibilities is, so you cannot carry, here it is x, you cannot, 0 means you cannot consider all these objects, that is 0 0. If you can consider the first object, so for example you can consider the fourth object, here it is 0001, like here consider it is a second object only, third object only, this is like that we are considered, here it is 1111. So here it is total is the 0 to 15, that is 16. That means here the 4 objects is there, then here it is a 2 power n, this is the time complexity big of 2 power n. So here in this example, if you can consider the 4 object, that is 2 for 4, that is 16. So like that here the number of object, n number of object, so the time complexity is big of 2 power n. So but in top down approach or bottom up approach, here the time complexity is big of n into w, n into w. Here n is the total number, here n is the number of objects, w is the total weight, the bag capacity, that is w. So here you can solve this problem. Here it is 01 knapsack means that object is not divisible. In fractional knapsack problem, that object is divisible. We can take the fraction part also. But in 01 knapsack problem, the objects are like washing machine, fridge, like microwave oven, like that. You cannot take the part of that object. So that is 01 knapsack problem. If you can carry that complete object, or you can ignore it. If you can carry, if you can consider that object put into the bag, then the x value is 1. Here if you cannot consider, you cannot put that object into the bag, that x value is 0. So either xi value is either 1 or 0 only, okay, cannot consider any fractions. So here it is a maximization problem. If here any problem is maximization or minimization problem, you can use the dynamic programming approach. So here it takes the sequence of decision, which for example you can consider this object, you can get the profit, and if you can consider these two objects, if you can get that profit, okay, which are the object you are choosing, so you can take each and every step, you can take the decision. So here dynamic programming approach you can use in this case. Now we can discuss, here this is the example having the weights and profits. So for example here there are 4 objects is there, object 1, object 2, object 1, object 2, here it is object 3 and object 4, 4 objects is there, and weights profits of those objects, that is 2 3 1 4. So you can solve this, the weight knapsack bag capacity is 8. So that's why here it is, you can see the tabulation method here, what are the values is there, the values will be stored here, the profits is stored in this table. So the total capacity, NAC capacity, bag capacity is 8. So here the bag is divided into 8 is divided into subparts like 0 1 0 to 8. So here the row indicates I, that is 0 to 4, but 4 objects is there, and here it is w, okay, w total weight is 8, so 0 to 8 you can write here. Then here it is, for example here the weight is weight here w of I, here it is p of I, profit of that particular object. So for example, if we can consider all these object, the weight is okay 3 plus 4 7 plus 6 13 plus 5, that is 18. Total weight is 18, all object if we can consider, but the back capacity is 8. So that the problem is solved by using dynamic programming approach. You can choose only weight 8, you can get the maximum profit. Which are the object you are consider, then you can get the maximum profit. So that's why you can solve this problem now. Here the weights, you can take the weights in ascending order like 3 and 4 and 5 and 6, but here it is 6 5, but I am consider the 5 6, here the 5 6. The profits are 2, the profit is 3, here the profit is, if we can consider the 5, the profit is 4, here the profit is 1. Now if you can store the profit in this table, for example here you cannot consider any object, okay, any object you cannot put into the bag. For example, here this is the bag, the bag capacity is 8. So in this case I am not consider any object this row, that's why you cannot get any profit. If you can carry any object, then sell them that object, you can get that particular profit. But here you cannot consider any object, this 0th row, so you cannot get any profit, the profit is 0. So you can write, note down here, it is 0 0 0. Now you can see here the back capacity is 0. Then if you cannot consider any object, you cannot put this object into this particular bag, the back capacity is 0. Now you cannot put into this object into the bag, so here it is 0. You cannot, if you cannot put that object into the bag, then you cannot get any profit. So the 0 profit, here it is 0 and 0. So this is the first step. Next step, here you can see, for example I am consider this row, then you can consider only this object. I am consider the first row, you can consider only this object. For example, in second row you can consider this row, then this object along with this object also you can consider. Okay, like that you can solve this problem. Now you can see here the object weight is 3. So here the back capacity, here it is 1, here the back capacity is 2. So you can put this object into here. Okay, if you can put this object into the bag, if you can put this object into bag, that is 8 minus 3. So remaining capacity is 5, remaining capacity, like that. Here I am consider this object, then that object is put here, then you can get the profit to 2. So you can note down the profit here, you can note down the profit, not the objects. So if you can carry this object into the bag, then you can get this profit. So the profit is 2. So here I am considering, in this row I am considering only one object, so there is no other objects is there. Then here it is maximum profit you can get only 2. Maybe the back capacity is 8 or 7 or 6, but here I am considering only one object in this row, that's we can get the maximum profit is 2. So in this case here you can see what are the values is there in the previous row are here, which is the maximum, you can consider the maximum one. So I am considering here it is 0, here it is also 0. Okay, then here you can see in this row you can carry, if you can consider this object along with this object also. For example, you can see here it is, for example you can consider the both objects 4 plus 3, that is 7. 4 plus 3, that is 7. So that objects, those two object is put into in this place, because the back capacity here it is 7, here it is 3 plus 4, that is 7. So that object is, those two object is put into the bag, then you can get this profit 2 plus 3, the profit is 5. Now here it is a constraint, you can see here what is the constraint means. So you can get the maximization, you can get the maximum profit, that is equal to, this is the objective pi into xi, pi into xi. So I value is 1 to, here the 4 object is there, 1 to 4. So it is a maximization. So you can get the maximum profit. So this is the objective. What is the constraint? The constraint is, the condition is, here it is w of I into xi less than or equal to back capacity. For example, here the back capacity is, 8. So here you can see, for example, in this case a back capacity is 7, here it is a 7, you can consider it. So if you can consider these two objects is stored in this bag, because here the 4 plus 3 7, so 7 less than or equal to 8, the condition is true, then you can put this object into the bag, then you can get this profit 2 plus 3, that is 5. Okay, so this is the constraint. Here you can get this maximum profit. Now here you can see, here already you can consider this object in this first row. So what are the properties you can get? Here also you can note down the same thing. So here the back capacity 8, but here you can consider only in this row, you can consider only these two objects, 4 plus 3 7, but you can get the profit is 5, so that you can write the same profit here also. Now in this row, you can consider, in this row here you can consider this object along with these all the objects. So but here you can see this object weight is 5 plus 4 9 plus 3 12, but back capacity is 8. So which are the object you are considered, then you can get the maximum profit. You can choose object like that. So that here you can see, here the 5, if object weight is 5, then you can get the profit is 4, where you can put this object. Here the back capacity is 5, then you can put this object, then you can get the profit is 4. So you can note down here the profit is 4. Here previous, here you can see what are the maximum, here previous one or previous row, you can take that values directly, here it is. Now you can see here in this case, here you can see 6, the back capacity is 6 here. Now what are the object you can carry? 5 plus 4, it is 9, but capacity is 6. Here it is 5 plus 3 8, the capacity is 6. So you can carry only this object, then you can get this profit only 4. For example, in this case here the back capacity is, now the back capacity is 7. Here it can take 5 plus 3, it is 8, 5 plus 4, it is 9. For example, 4 plus 3, it is 7. So you can consider these two objects, you can get the profit is 5. So already 5 is there in previous row, you can note down the 5 here. You can see here it is 8, back capacity is 8. Now you can see 5 plus 3 is 8. So if you can carry this object and this object, you can get the profit 4 plus 2, that is 6. So already 5 is there, 6 is the maximum. For example, here you can see 4 plus 3, it is 5. 4 plus 5, that is 9. More than that, the back exceed the back capacity here. So you can consider 5 plus 3, then you can get the profit is 6. So can get the profit is 6. Now by using the formula, you can fill this table. So here in these 4 rows, without using the formula, I can fill it. Now you can see the how can use this formula, how can fill this row. Now it can see here it is max m of, here it is I value is 4, here it is w is 1. So 4 comma 1, that is equal to maximum of m of I minus 1. So I value is 4, 4 minus 1, that is 3. Here it is w is 1, comma m of I minus 1, that is 3, comma w is 1 minus w of I. So w of I is, for example, here the w of 4 is 6. W of 4 is 6. you can note down the 6 here, plus p of I, the p of I. So p of I value p of 4, you can get the properties 1, so you can take the 1 here it is. So m of 3 1, m of 3 third row first column, the value is 0, so here it is 0. So in this case m of 3 comma 1 minus 6, that is minus 5 plus 1 here. So there is no exist this location in this table. Okay, negative index is not there in the table, that's why you can consider here it is up to this one. Here you can see the 6, so up to this position you can get the negative, so that you can write what are the values he is there in third row, and here it is 3 of 1, the same value you can consider here, 3 of 2 same value you can consider, 3 of 3 the same value here consider, 3 of 4 the same value you can consider up to this, and 3 of 5 the 4 here consider here. Now you can see m of here it is 4 comma w here it is 6, w here it is 6, here it is 6, that is equal to maximum of m of I minus 1, that is 4 minus 1, that is 3 comma w. So w is 6 comma m of I minus 1, that is 3, 4 minus 1 3, so here it is 6, so w is 6 minus w of I, that is 6 minus w of I. W of I means w of 4, w of 4 is 6, w of 4 is 6 plus p of I, that is p of 4, p of 4 is p of 4 here it is 1, p of 4 is 1, you can note down here it is m of 3 6, m of 3 6 means here it is 3 6 third row and sixth column, here it is value is 4, the property is 4 here. Then here it is m of 3 comma 0, 6 minus 6 it is 0, 3 minus 0, that is 3 minus 0, that is 0, so 0 plus here it is 1, so that is equal to which is the maximum, 4 or 1, 4 is the maximum, that's why here also you can consider the 4, because you can see here the object weight is 6, so you can put that object here, but if you can put this object you can get the 1, but already 4 is the maximum, so that's why you can take the 4. So here also you can fill it like that, whatever the maximum is there you can take that maximum. So if you can put this object, if you can get 1, but instead of you can put this object, already you can get the maximum profit 4, so that you can take this previous row value, so that is 4. Now you can see, you can apply, if you can find out 4 to 7 also, 4 to 7 also you can find out. For example, you can erase this. Meanwhile, you can calculate that value m of 4 to 7. Here it is. Now we can see. So here you can calculate it 4 to 7, m of 4 comma 7, that is equal to maximum of m of I minus 1, that is 3, m of 3 comma w, that is 7, 3 comma 7, comma m of, that is 3 comma w, w is 7, 7 minus w of I, that is w of 4, that is 6, plus p of I, p of I is p of 4 value is 1. So here the m of 37, maximum of m of 37, 37 here it is m, here 37 value third row and seventh column the value is 5, so directly can note down here the 5, and m of 3 comma 1, here the value is 1, m of 3 comma 1, m of 3 comma 1 value is 0, so 0 plus here it is 1, so which is the maximum, so this is the maximum, so that you can write here it is 5 only. Like that here also you can find out m of, that is I value is 4 comma 7, that is equal to maximum of m of I minus 1, that is 4 minus 1, that is 3, comma here it is w, that is 7, comma m of I minus 1, that is 3, comma w is 7, 7 minus w of I, so w of I value is w of 4, w of 4 value is 6, plus p of I, that is p of 4, phi of 4 value is 1. So here it is maximum of m of 37, m of 37 value is 5, 37 value is 5, then here it is 3 comma 1, so 3 comma 1 value is 0, so 3 comma 1 value is 0, so 0 plus 1, that is 1, here it is a maximum, here it is maximum m of 37, here you can consider 8, sorry here it is considered 8, because here it is 8, now you can see 4 8, that is here 3 8, m, here it is 3, here the w is 8, 8 minus w of I, that is 6, 8 minus 6, then plus p of 4, that is 1, okay. Now maximum of 3 8, so 3 8 value is 6, here it is 6, comma here m of 3 comma here 8 minus 6, that is 2, plus 1, so you can see m of 3 2, third row second column value is 0, so 0 plus 1 1, so which is the maximum, 6 is the maximum, so that you can take 6 here. Now so you can get the maximum property 6, you can get the maximum property 6. Now how you can get the maximum property 6, you can, what are the object you are consider, what are the object you are put into the bag, now you can see 6 is there in this row only or previous row also 6 is there, that means 6 is not because of this object, so 6 is because of this object, so this object is considered. Now you can see here it is, for example here I am note down here the x value, 4 object is there, 1 object, second object, third object and fourth object. Now I am considered here it is, for example in this case these are the 1 2 3 4 objects, otherwise you can note down 1 2 4 3 object, otherwise you can note down 1 2 4 3 object, because of here you can consider the fifth one first, next last here it is, you can see, okay. So 6 is the property 6 you can get because of this object, fifth, if we can carry this, so the total weight of the bag is, capacity of the bag is 8, so we can consider this one, that is 5, the remaining is 3, and also here the maximum property is 6. So maximum property is 6 minus, so if you can consider this object, you can get this profit, that is, so remaining property is 2. Now you can see here it is, where is the 2? You can see here the 2 is there in this row, 2 is also there in this row also. So 2 is because of this object, you can consider this object, you can get the properties 2. So that, so the weight of this object is 3, so 3 minus 3, so remaining back capacity is 0, so here it is 2 minus, if you can consider this object, here also you can consider this object, these are the two objects here consider, 3 and 5, here then you can get the properties 2, so that is 2 minus 2, 0. So here you can consider this, so you can see, you can note down the objects, here it is, for example you can consider the this one, fifth weight, that is fourth object you can consider, fourth object you can consider, here it is, xi value is 1 comma 2 and 3 comma 4, xi value is, for example you can consider this object, so that it is 1. Okay, if you can see that 3 third, here it is 6, but here you cannot consider that, so it is 0, the x value is 0. You can see here it is, you can consider this object. Okay, second object you cannot consider, so 2 is there here, the previous row also 2 is there, so that this object you are not considered, that is second object is also not considered, then 2 is there in previous row, so that this object is considered, you can get the properties 2, so here one object is considered, so that here the here you can see your pi into xa, that is xi is first one is and last one, so that here it is pi is p1 into xi, that is 1, I am not considered the zeros, here it is, that is 2, properties 2, plus here the last one, last one properties, that is 4 into 1, that is 4, here the properties maximum 6, like that here also wi into xa, so you can consider this one, so that is 3i into xa, that is 1, plus here it is 5 wi into 5, that is 5 into xa, that is 1, here it is 5, that is equal to 8 less than or equal to 8, so that, so object, what are the object here considered, these are the object here considered, here this object you can consider, and this object weight is you can consider, then you can get this profit, that is you can get this profit 2 plus 4, that is maximum profit is 6. Okay, so later classes here discuss one more example for 0 1 knapsack problem by using set method. Thank you for watching this video.